Welcome to the lecture halls of PLC University, the academic home to the PLC professor. This is going to be one of the general lectures of programmable automation controllers. If you've watched any number of our videos, you know that this normally says programmable logic controllers. These general lectures are specifically on the Logix engine, the processors that support the Logix engine, and the manufacturer refers to them as programmable automation controllers. This particular lecture is going to be on hardware and software compatibility, specifically aimed at flashing firmware, or as we like to say in the business, talking with strangers. What I mean by that is, whenever you approach a controller and you don't know anything about that controller, it's like approaching a stranger. There are very specific and very efficient ways of going about making first communications and making sure you're on the same page or the same firmware level. Because the firmware level in the processor has to match what you have for RSLogix 5000, or vice versa. RSLogix 5000, you have to open a version of 5000 that is the same as the firmware on the processor. So, we meet up with a processor that we've not met before. We've met one that looks just like it. In this case, I'm going to do this with the L31, 1769 L31. I have about a dozen of these sitting around. I use them for training purposes. And when I buy these, I have no idea what rev level is on these processors, what they've been flashed to. So I'm going to go through the process of talking with strangers. The first thing we have to do is establish communications with the processor or get their attention. To do that, we open up RSLinx Classic. And I'm going to do an RSWho to see if it shows up. You see that red X? That red X means that in a prior instance, RSLinx RSWho found a CompactLogix processor on the DF1 driver. It found it out there at the end of the cable. This time it doesn't. Now that doesn't mean it's not out there. That can simply mean that what's out there is not set at the same baud rate, or the communications configuration on the other end doesn't match this end. As soon as I see that red X, I usually close RSWho and I go to the double-headed snake here, configure drivers, 1 byte from one of these boys and it's a hospital job for sure. Pick the DF1 driver, we go to configure. You see it's already set up for Logix, CompactLogix, but it says 38.4K baud rate. So I'm going to click on auto configure. Auto configuration successful. Sure enough, it was 19.2. That's why we saw the red X at the other end. I'll move this up a little bit. Oh, that's right. We got plenty of screen. Click OK. I can close the configure drivers. Now I can open up RSWho. Expand the DF1 driver. The red X is there, but it's there it goes. So now we know we're good. Now I'm going to right click on this. Now that I can communicate with this PLC out there, this PAC, this controller, right click, device properties, and I can see that this is Rev 1.015. I don't know how many years it's been since I've seen something at that early of a revision level. That's amazing. Remember, the factory doesn't know what rev level you're going to run this processor at. I know it's at 1. I don't want 1. I want something higher. In all of our courses, we are currently using Rev 20, revision level 20. It is the highest level of what I call the 17 through 20 era. And later on in the presentation, we'll elaborate a little bit more on that. I can see it's out there. I can talk to it, minimize links, and now I'm going to open up. There's 2 ways you can do this. I think I'll demonstrate both. In the first case here, I'm going to try to download a program. Now this is a typical little program that I have that I use for testing these L31s. I have 6 inputs and 4 outputs in some logic here. I'm also doing a GSV, get system value, and a set system value. This GSV is accessing the class name wall clock time, the particular attribute, date time, and the first dent in that 7 dent array. If I change this time here, now as I go in and I actually right click, monitor, I can expand that and I can change some values. See, I have panel view date time and controller date time here. I can put values in here. I'm not going to do that because that's not what we're working with today. If I can set the controller date time to something, then if I toggle this toggle switch, it will do a set system value, and whatever I put in here now goes to this tag, and this tag would go to the panel view. This is just a little program that I use for testing. So I want to download this to my controller. Now remember, well, here, I'll click on this. See, I'm at Rev 20.12. I'm trying to download a program developed in RSLogix 5000, revision 20, and I'm trying to download it to an L31 that is flashed. The firmware is flashed to Rev 1.15. If you're not familiar with the terms hardware, firmware, software, it's exactly like it sounds. You've got hardware, and then you've got software. Software is squishy, easy to change. Hardware, you really can't change it. Then there's something in between called firmware. Firmware, it's not hard and it's not soft, it's just in the middle. It's kind of firm. It can be changed, but not easily. Hardware cannot be changed. Software can be changed easily, and firmware is kind of in the middle. And when you download a program to a controller, the revision level of that program has to match the revision level of the firmware that is in the memory of that controller. It is the firmware that is the guidebook, the rule book, the operator's manual, if you like, for the program that you downloaded. So we're going to go ahead and try to download. We know we got communications. So I'm going to go up to communications, who active. I'm going to pick this processor. Notice it's already kind of highlighted and already shows download. But I'm going to click on the processor so it's real obvious, and I'm going to say download. Now I know it's not going to download, and there are two ways you can do this. You can flash the processor, then do download, or you can start the download. Then it's going to come up and give you this message: unable to download to controller. The revision level of the offline project and the controller's firmware are not compatible. Notice it doesn't say online project. There is no such thing as an online project. You have offline projects and you have online program and data files. It's telling you what you have. Firmware Rev 1.15 and my program's at 20.12. That's okay. I want to update the firmware. Now we won't hang around for all of this because this takes a long time because we're doing it through RS-232. Very slow. Okay, so here's the particulars again, 1.15 to 20.12.79. Hit update. And now it says updating the module's firmware from 1.15 to 20.12.79 and some warnings. Yes. Okay, now that we've started this, if we were using 100 meg Ethernet, this would go fairly quick. But I want you to notice it says transmitting block 90 something of 22,174. Well, if you look at the progress bar, I don't even see any progress. We'll wait a second here. We're going to pause this here in a second, but let's wait a second and see how many blocks you have to have before you even get the first inkling of progress. There are things that can bite you in the butt. Oh, I see a little tiny blue sliver showing up right there. Maybe, maybe not. If the controller is not in the program mode, if it's in the run mode, when you try to do this, it won't complete the flash update. It has to be in the program mode in order to do that. In some cases, you may even have to unplug the battery and let the processor sit for a couple hours to make sure the capacitor drains off, if it has one. Okay, now we got a little bar down there. And by the way, notice what it says right here. This is extremely important. Failure to maintain power and communications to the module during the update may render the module inoperable. Does that mean it renders it into a condition where it will not function unless you redo the flash? Or does it turn it into a brick? Well, it can be both. It could be something where you have to restart it, but it will restart. And in other cases, I have heard of instances, I've never experienced it myself, where it actually turns the controller into a brick, meaning basically worthless, and you're going to have to send it somewhere to get it slapped around a little bit and wake it up so it can be used again. I'm going to pause the recording now because you can see at this rate, that's our progress bar, it's going to take 20 times what it's already taking. So it's going to take 20 to 30 minutes to perform this operation. So I'm going to pause and then come back. While we're waiting for that processor to have its firmware flashed, let's look at some compatibility issues. This is a list of the 1756 ControlLogix, abbreviated CLX. Most often you see CLX for ControlLogix, CPX for CompactLogix. This is the recommended list of processors if you're going to go buy one to learn with. And the reason this is recommended, this group, the L6X series, is because of the cost and the maximum RSLogix 5000 major version that you can flash it to and use to program it with. And as you see, the minimum version varies between 12, 14, 16, 17, and the maximum is 20. I like to think of 17, 18, 19, and 20 as the current mainstream era of revision levels. There's newer levels than that. As a matter of fact, you see down below it says current. That would be version 21 and up. And at some point this chart will change. The upper group, the 1756L1, that was the very first processor back in, I can't remember, it's been quite a few years, 15 years ago. If I thought about it, I can remember the date. I remember at the introduction of the L1 at Automation Fair in Nashville, Tennessee. It was a major quantum leap in processing for industrial controllers. But anyway, look at that first group. The minimum is not as important as the major is. And although 17 is in that era of 17, 18, 19, and 20, it's just barely in there. Also, an L60 MO3SE is a special processor that has a built-in motion capabilities for Sercos. So it's unlikely that you would find an L60 M03SE. But if you do, you cannot flash it higher than 17, which means that 17 is the highest major rev level of 5000 that you can use to program it with. The group down below, I show those in yellow. Those are actually better than the group in the middle, meaning that they all are supported by the high end of the 17 through 20. So if you look down through the list, you don't see 17 anywhere. So 17 is kind of a gray area. So if you look up above, you see that 17 is the lowest or the minimum for several of the recommended ones. Now remember, I'm recommending that middle group in green based on price, not on capability. The bottom group in yellow has more capability. Those are all L7X ControlLogix processors. If you buy one of those, you can use one of those well into the future for your learning purposes. Typically, when people buy a controller for learning, they work with it for 3 to 12 months and then they're done with it. Then they're off working someplace and they no longer have necessity for it. So that's why I'm recommending the group in the middle, the L6X for ControlLogix. And you notice a subscript there, 1 and 2, 17 with the 1 there, the L60 MO3SE, excludes GuardLogix software version 14. If I remember right, version 14 was one especially for, I think, General Motors or some big customer. And then, of course, you see 2 excludes RSLogix 5000 software version 15. So that's kind of a fly in the ointment on those 2 right there. It doesn't include version 15, even though it shows 14 to 20 for both of those. It does not include 15 5000. It doesn't include ControlLogix for 14. Next we come to CompactLogix, both 1769 and 68. I started to type 1768/69 simply because 68 comes before 69. However, the 1769 processors are more prevalent than the 68. The 68 are only the L43 and L45. So there's a very narrow group of products that have the bulletin 1768 designation. CPX short for CompactLogix. Now our green group here, these are the ones that I recommend that you look for if you want to purchase your own hardware for learning purposes. In the top group is the 1768 L43, L45 series. Of those, the L43 is going to be the least expensive. Now notice everything in green has a maximum rev level of 20. The minimum rev level is really not that relevant, but the maximum is, because you want to learn with the highest possible rev level, which has the most features. Now the other group that says current, and there's some other ones there that aren't marked yet that say 13 for maximum, they're going to pop up here in a minute. So let's just stick with what's in green right now. So the top group is 1768. That comes in two flavors, 43 and 45. One has more memory, less memory. These processors, the 43 and the 45, have two backplanes. They have an active backplane to the right. As you look at the processor, the active backplane, which uses 1769 I/O modules, is to the right as you look at the processor from the front of it. Not out from it, but looking at it. And to the left is the passive backplane. Passive means that the controller is not controlling the backplane, so it's passive. Active, the controller controls the backplane, so it's active because it activates the modules across the backplane. The next group there, L23, you have E and just L23. The E means Ethernet. If you were going to purchase an L23, the least expensive one is going to be the QB1. And it's both of those that have the E designation will give you Ethernet, which is good, but it's going to be more expensive than an L23 non-E. So the bottom of the three there is the least expensive to find, on the internet. Now, I'm talking used, not brand new. I'm not even sure which of these they still make brand new. And it really doesn't matter, because I'm recommending that you buy used hardware, and there's many vendors out there. You don't have to buy it off of eBay. You can buy it from any number of a half a dozen vendors out there that sell used hardware. It's taken out of running machines, it's tested, and then resold. I have purchased dozens of processors and controllers used, and I've never had one that didn't work. Rockwell Automation makes really good hardware. All the PLC manufacturers make good hardware. And I have yet to see a piece of hardware from that manufacturer that just died on its own. Bolt of lightning, wired it up wrong, abused it. Yes. Buying used stuff is from this manufacturer or made by this manufacturer. And of course, if you do it on eBay, make sure you consider the seller's ranking as far as 100% positive feedback. Now, anyone can get negative feedback. If it says 96% positive feedback, go look at what the negative is and then decide for yourself. And you want to test this stuff as soon as you get it. Don't let it sit around for 2 months waiting to get everything else, all your ducks in a row. You probably want to buy the least expensive things first, like the power supply and the I/O modules, then your processor, so you can test the processor immediately. Go a little further down the list, and these are of a little bit newer, the L31, 32C, C for ControlNet, E for Ethernet, and then CR ControlNet Redundant, and L35E. So 31, 32, 35, more memory as you go up in numbers, ControlNet, Ethernet, or just RS-232. The L31 has 2 RS-232 ports. In red, the L20 maximum major revision 13 and the L30 maximum 13, and then the L33, 34, and then you know, I kind of included the DriveLogix. I don't care about FlexLogix and DriveLogix for this lecture. They were in the list, so I just included them in case somebody happened to have one laying around. If you're going to use FlexLogix, it kind of went the way of the Edsel many moons ago. And there was nothing wrong with FlexLogix. It worked fine. It runs the Logix engine, but the physical format wasn't that popular. People liked either the compact or the control. They just didn't like the physical shape and installation of the FlexLogix. DriveLogix, that's a whole different ballgame. We're not even going to talk about that. I would avoid what's in red here, mainly because you're not going to be able to program it with anything that even looks like the latest software, version 13 in most cases. You don't want that. And then, of course, in yellow, we have, I didn't mean for that to pop up yet, but it did, so that's fine. You can see there are some items down there, both in green and yellow, that have a 1 next to it. Remember, 1 excludes GuardLogix software version 14. Nonetheless, in yellow, at the top, and notice that these all say current for the maximum RSLogix 5000 major version. That means that you can program them with version 21, which is 5000 Studio, and version 2, if that's out, 22, 23, and so on. So if you do purchase one of the new L1, L2, L3, 5370 series, it's going to have a long lifespan for you to work with. Typically, again, 3 to 12 months and you're done with your training hardware. You sell it on eBay, give it away, lend it to a friend, and off you go on your career. So the yellow, and notice down there that there is SoftLogix down towards the bottom. We're not going to talk about SoftLogix. I'm really only concerned primarily with CompactLogix. If you happen to buy a 1756 ControlLogix, it's a little more expensive. The modules are more expensive. The backplane's a separate piece of hardware. It's not built right into each module like 1769 and 1768 I/O modules for CompactLogix. And by the way, there are only a few 1768 I/O modules. There's an Ethernet bridge card, I believe ControlNet bridge card. There's a Circos MO4 SE. There are just a few cards available 1768 for the passive backplane on the L43, L45. Now, going a little bit further, RSLogix 5000 version, notice you go lower as you go down the list. It starts with 20. Now, 20 is not the current, but that's the one that we are most concerned with because I'm doing all of my training development for 20. It will be quite a while before I jump to 21 or higher, simply because there are many people out there that have available from work version 20 or lower for software. It's very expensive software. And you can find lots of hardware out there that you can flash to firmware 20 and lower. So 20 is pretty much my benchmark for this training. Now if we look across that list there, I'm not concerned about 16 and below, 16 and 15. I'm only concerned about 17, 18, 19, and 20, and really not about 17. I kind of included into that same era, but I don't recommend going with 17. And you can see the RSLinks Classic version that is recommended compatibility-wise with those different 5000 versions. And this is definitely something to pay attention to. I don't know how many times I've gotten questions or seen discussions on the blog chats where people are having trouble doing certain things, and it turns out to be a slightly different SR level. See, they're all CPR 9, Coordinated Product Release 9. They all came out at about the same time, but notice there's SR1, SR2, SR3, and SR5. And you see SR4 over under Factory Talk Asset Central. But for RSLinks Classic version, that is your primary interest at this stage in your learning process is that you have an RSLinx Classic version that is compatible with the RSLogix 5000 version. And then, of course, when you load 5000 in any of the more powerful platforms, you're going to need Factory Talk Services platform. That's not something that you buy separate. That's something that comes with 5000. But notice there is a slight difference there. Notice that there's 2.1 twice, 2.3 and 2.5. So you're going to want 2.5 if you're going to use version 20 or 20.01. Once again, compatibility. When I look at this group right here, I clipped off, by the way, 16 and earlier. You see it starts 20, then 19, 18, 17. We really don't care about 17, but I'm including it because there are some overlaps. Here's an example of where you would use this chart. The L63 XT and MO3 SE, L60 MO3 SE, it does show up in 20, and one of them shows up in 17, but look in between. Look in between, L63 XT. I don't see it in version 19 and 18. So you have to be careful if you're going to use one of these more obscure controllers. So if you look at that group, 1756, and we know that the L1, L53, L55 isn't going to really do it for us because those work all the way over with some of the older rev levels. So we're basically going to be after the L6X, L61, 62, 63, 64, and 65. And then down below you get the L7X, and those are all compatible with 20 and up. And you see some of the L7Xs will even support firmware at 18 and 19. Once again, we have another compatibility chart here. And in this chart, we have a whole area that's not even applicable. So if you look at the CompactLogix in the first column there, that starts at L16, 18, 24, 27, 30, and 33, those are all the new L1, L2, L3, 5370 controllers. That's the whole new platform, completely brand new chipset, and that works with version 20 and up. And then, of course, this other group that we don't care about is 15 and 16. But you also see there FlexLogix. It says not applicable, which means FlexLogix was not supported for 17, 18, 19, and 20. But you see under the yellow with red border that the L34 was supported, version 16 and version 15. If this is all you have to program with, I mean, let me be very clear. If you have a free FlexLogix 1794 L33 or L34, especially in L34, we'll just say specifically in L34, the 33 would be in another column further to the right here that I clipped off when I did this screen capture. You can use that to learn with. You can do basic programming, but you're going to have RSLogix 5000 version 15 or 16 to work with this L34. Then you're going to need some FlexIO. Now actually FlexIO is not that difficult to find. So you could take the route of an L34. You could even go an L33 and go further back with your RSLogix 5000 version. The reason you're seeing all this, folks, is so you can make an intelligent decision on the route that you want to take to obtain hardware. If you have software free to you that's version 16 and you can't get 17 or not, by all means you want to pick something that version 16 supports. And on this list, that would be the L43, L45. Next up, we have another chart. And by the way, I just went and looked at our processor that's getting its firmware flashed. It is just now halfway done. And the amount of time that it's taken is more than what you've just sat and listened to other matters on this subject, because there have been pauses in between sections where I went and looked to see how far it was and decided it wasn't worth mentioning yet. So flashing firmware using 38.4 or 19.2 baud rate. Remember, 19.2 takes twice as long as 38.4. And you might think for downloading a program it's not a big deal, and it's really not. But when you're going to flash firmware, the longer that it takes, the more vulnerable the process is to power failures and interruption of communications. I'm running at 38.4, probably. I don't remember now. Maybe it was 19.2. I think it was 19.2. And of course, I can't get online with a processor. That processor was at Rev 1. I would have to jump through all kinds of hoops to get it bumped up to 38.4. So whatever it was at, 19.2, that's what it's running at. Okay, looking at the chart in front of you. Here we have the real hard center of CompactLogix. 23E, which is a fixed, roughly, it's not really a fixed I/O, but it's a brick, meaning that it has a processor and it has some I/O built right into it, all one device. Power supply, processor, and I/O. And by the way, these, all of these that have I/O built into them, CompactLogix, they require 24 volts external power. You can't power them with 115 volts AC. You have to use a 24 volt DC external power supply, which is not a problem. They're not very expensive. The L23E and L23 without an E, meaning it doesn't have Ethernet, it's very compatible with 17, 18, 19, and 20. That's a good piece of hardware to purchase. And then the second group, L20, 30, 31, be really cautious what you're doing here. Because remember, I clipped off several of more columns to the right. You're not seeing the whole chart. In other words, when you look at L23E and L23, and then you look under 20, under 19, under 18, and under 17, you see them there. Okay, and they're all Series A, right? That hardware is compatible across those four major revision levels, major version levels. But look under CompactLogix L20 and up. You do not see L20 or L30 anywhere in those columns. The L20 and the L30 are Ichabod, or meaning stay away from those. If you've got one free and you've got software of an earlier version like 16, 15, 14, I think 13 is the highest that will work with the L20 and the L30. So you would have to have access to RSLogix 5000 major version level 13 or older to use an L20 and L30. L31, 32, 32, 32C ControlNet, 32E Ethernet, 35 ControlNet redundant, and L35E Ethernet, L31 and up. That's what you're really working with, those. Or one of the bricks in the first row up there, an L23 of some sort. Now, and the ones down below, DriveLogix, FlexLogix, those are outside the, what would you say, they're outside of what I'm going to discuss in this lecture. Now, you can find all this information under, if you have software, you can open up the revision notes and you can read down through there. You can get all this compatibility information. I'm just including it all here for your convenience. Okay, electronic data sheets, EDS files. In RSLinks, if you have an object that shows up in the path in the tree of communication devices, and it's not a red X, but it's a question mark, it may be that it sees it, but it doesn't know what it is because RSLinks does not have an electronic data sheet for that particular part number. If that happens to you, then you can go on the internet to www.rockwellautomation.com, resources EDS, type in the part number, and you can download the EDS hardware, the EDS sheet, the electronic data sheet. Download all those into a folder somewhere on your hard drive. Then you can go into Rockwell Software, RSLinks, Tools, and find the EDS hardware installation tool. This also works the same way for DeviceNet, Ethernet IP, and ControlNet if you want to download EDS files. Well, look at this. I fooled around for 5 minutes or so before I started recording the first screen that we were looking at. We're at 15,730 blocks out of 22,174. You can see that this takes quite a length of time. So we're going to pause again. And when this is almost done or done, we'll come back and then we'll continue, because we're going to do this twice. I did it through a download. I'm going to go back and do it the other way, which is probably more efficient. And we're not going to make you wait and sit here and look at this tick along at 15,937, 44, 58, so on. Okay, it's done flashing. Remember that we started all this with in the process of trying to download a program written in revision 20 to a processor that had its firmware at version 1, the very first version. It interrupted the download process. We flashed the firmware. That took a good half hour, 45 minutes, and now we can continue the download. I might clip some of this out. Now, this is an interesting message. The online serial configuration is different from the offline serial configuration. Applying the configuration changes may result in a loss of communications and the inability to reconnect to the controller. Do you wish to apply the serial changes? Now, what you probably didn't know was the program that I'm downloading is probably set at 38.4K baud rate. And if you remember right, we flashed this at 19.2 because that's what the processor was as we got a hold of it. So I'm going to say, yes, we will lose communications. And once we've lost communications, and I'm doing this on purpose, I'm throwing this in as a bonus. And if you don't want to watch this, just fast forward. As is always, if I'm going too slow or you don't like what I'm saying, fast forward until you see something that you like. Eventually it's going to time out, because the instant that I said yes, update the baud rate for channel 0 to 38.4, the instant that took effect, we lost communication. So all of this time that we waited, and I probably clipped out some of it, it was in a timeout process. So we'll say OK. Now we go back to links. We go to the double-headed snake, configure drivers, go to configure, auto configure, and you see it'll auto configuration successful at 38.4. We'll say OK. We'll close that. We'll minimize links. And we already downloaded, so I will close this. I can go online in several ways. I could do it from here, or I can do it from communications. I always recommend you go from communications, just in case there's more than one processor out there, you can see where you're going. So there's our processor. Go online, remote program, I/O OK, controller OK. Correlation required. Changes will be uploaded from the controller. Save the project before correlating. No. In your situation, you might have picked yes, but in my situation, I didn't want to change my offline project to match whatever might have been in that controller. I don't know what the variation could have been. So I'm in the remote program mode now. So I'm going to go to run mode. And I'm going to flip the toggle switches on. You see that turned on output 0, output 1, output 2, and then 2 more switches, 3 more, turns on output 3. And you can see the time in here. Well, you see over here it says 1998, and there it says 0. So let's go to monitor, and we'll expand this one. So this is what's in the controller right now, 1998, and that's kind of the default time base. Now I'm going to try something I wasn't planning on here. I'm going to close this. I'm going to go up to view and turn on watch, and I'm going to drag this up, and I'm going to expand. Well, it looks like we can't get this whole display in there, so I'll show you this one so you can see that it's all zeros. That's this one over here. This one at the top it's only showing control date time of the first integer, and I want to see the entire array of 7 double integers, and I'm not going to be able to display that here. So I'm going to take and flip on this switch. See 1998 here, watch over here. Okay, now we're back in business. We've started a download. The firmwares didn't match, or I should say the revision of RSLogix 5000 did not match the firmware in the memory of the controller, so it interrupted the download to flash it up to version 20, and then it continued the download. Of course, you had to click on a button to say you want to continue the download, but it interrupted the download. Now we're going to do this a slightly different way. I just powered down the processor, actually powered down the system, swapped the processor with one that has revision 15 in it. We might want to download, but first I'm going to flash the firmware with something called Control Flash, which is really the software we just used. And Flash Programming Tools, you can't see it's over in my main menu, Control Flash, and it opens up. I'm going to minimize this. It's not really necessary because all the action takes place right in the middle of the screen. Stretch this out. Okay, this is Control Flash, and you could read the instructions if you want. I'm not going to read the instructions. I'm going to go next. I have a 1769 L31. Now, it does not know I have an L31. It just so happens that I've been sitting here flashing a half a dozen or so of these L31s to use them in class. And so the last thing I picked was L31, so it came up with L31. So it doesn't know that's L31, so don't expect Control Flash to come up and know what processor you have. You have to pick it. It just happened to be on L31. So next, then you have to tell the Control Flash through RS links where is that processor. Well, I've got it hooked to DF1. See, it shows the red X. Now, if it stays that way, we're going to have to deal with RS links. I thought it was at 38.4, but maybe it's also at 19.2. I don't like the way the red X stays there, so I'm going to say cancel. I'm going to bring up RS links, configure drivers, auto configure. See, it's also set at 19.2. So I'm going to say OK, close, minimize links, and try this again. The red X may appear, but it should disappear. There you go. So that we pick that processor and we say OK. Then it comes up and says, all right, do you want to flash it to 17, 18, 19, or 20? We want to go to 20. So I say next. You could read this if you want. I'll pause just for a minute. You can pause and watch it actually. And it gives you the serial number, the part number, the current rev, and the new rev that you're going to remind you what you're doing. Then you say finish. Are you sure you want to begin updating the target device? Yes, I do. Now you see that there's less steps involved this way than with interrupting a download. However, if you didn't know any better and you went to download and you go, oh, wrong firmware level, you can continue from there. RSLogix does have that built in. Of course, you know this is going to take a long time, like half hour, 45 minutes. I'm going to pause and then come back when it's done. 45 minutes later, update complete. Please verify this new firmware update before using the target device in its intended application. I do plan on doing that. So I'm going to say OK, and of course it wants to know if we want to flash something else. Keep in mind the Control Flash is the application that you flash the firmware in all Logix engine processors and all 1756 I/O modules and other modules that have flashable firmware. So I'm going to cancel and end this session. Now I'm going to open RS links and I'm going to look to see if I have my processor there. I get the red X. If the red X doesn't go away, then I'm going to have to, oh, it did, so whatever baud rate we've got set, it's the same on both ends. So I'm going to close that, minimize that, and open up RSLogix 5000 to our test program. Now I'm going to click on the processor properties, look at channel 0 serial port. It's 38.4. I like that. Now when we download, of course, we're going to lose communications, but let's go ahead and follow through. So communications, who active, pick our processor, download, wait. We want to download, and we will probably get a message that asks if we want to use the offline project communication settings or leave them as is. Now I prefer 38.4 communications, so while I'm here I might as well change it, let it go ahead and download 38.4's lose communications. See, the online serial configuration is different from the offline serial configuration. Applying the configuration, loss of comm. Do you want to apply? Yes. And of course, it loses communication, so none of this is active now. We can set and go through the timeout, or we can open up RS links, double-headed snake, configure drivers, select the DF1 driver, configure, auto-configure, 38.4, successful, OK, close, minimize, and come back. And what you just witnessed was something I've actually never done before, and that is it's lost communications, but it's in a timeout. I quickly went and changed the configuration in RS links, and it changed it quick enough that it was still in the timeout process. It caught communications, and now we're remote program mode. So I'm going to switch to run mode. And as soon as I did, I heard relay outputs on the controller that I'm using. One more to turn off. And there you have it. Go offline before we disconnect from the processor. Changes have been made. Save the changes. I'll say yes, because it all looks good to me. Okay, and that basically concludes our flashing the firmware and our compatibility. If you're unfamiliar with the PLC Professor's website and bookstore, this was the original offering. It was called the Complete PLC Learn Series. It was 3 manuals, Basics, Advanced 1, Advanced 2. There was also a 2-disc lecture set, about 12 lectures in the clear plastic case there. And then each lab project manual came with lab lecture discussions, such that you would have in a live classroom after you completed a lab, you would go over the labs with your instructor and discuss the results. For reasons of expediency, those 3 manuals were replaced with 1 manual that contained all 3 of those manuals as 1 manual. And this is, and still is, the Complete PLC Learn Series. The disc sets are still available. Some of them are free on YouTube, some of them are not. We also, on the website, sell MicroLogix 1000 trainers that are specifically designed to go along with the manual in the Complete PLC Learn Series. These trainers come in several different formats. This is the most common. Then we introduced RS 5000 Lab Projects manuals, and this is a roughly 200-page full-color manual, and it comes with a 4-disc set. Discs 1, 2, and 3 discuss the lab results, and the bonus disc includes a variety of things that you could find free off the internet if you dig deep enough. Once we finish volume 1, then we set about to produce volume 2, which is more advanced, RSLogix 5000 and the 4-disc set. The information disc from this set is approximately the identical information of the bonus disc from volume 1. I should back up and tell you that volume 1 does not start at the beginning for PLCs. it assumes that you already know how to program a PLC. So it is a transitional training package for people that already know somewhat of PLCs to make the transition over to RSLogix 5000. If you are new to PLCs, you should take the previous course first, the Complete PLC Learn series, complete that course, then do Volume 1, the basics. At that point, if you still want to learn more, then by all means do Volume 2, the advanced. In the Professor's Workshop, we have 2 online courses that were created by converting the Complete PLC Learn series to a learning management system format. They are complete. They are ready to be registered for. Coming soon, we will have a link on our website so you can register for this course. We also are building CompactLogix trainers with both digital and analog. We have Volume 1 of a new set of lab project manuals for programmable automation controllers. These 4 volumes are going to follow the same level of learning that the Complete PLC Learn series did. The Complete PLC Learn series used MicroLogix 1000. This 4-volume set will go through the same basic sequence, but with CompactLogix, or you could say the Logix engine, RSLogix 5000.